So I'm seeing some points here. I'm seeing the doctor gives you 15 milligrams initially, so that point is going to be 0.15. It says after 16 minutes, so that's the next point. There's 4.5 milligrams left, so that's the x and the y for the next part. And then let's see. So we can't. Let's see. So what we're going to have to do is find an equation for this. Then they're asking us to ask. Let's see. The alarm will go off for more than 2 milligrams. So what we're going to do is set our equation equal to 2 and solve for that. So let's get the equation first. So all we've got is our basic exponential equation going on here. And I know from the work we have done in the past that when I have 0.15 for basic exponential equation, that's going to be the a. That 15 is going to be the a. And then because 15 is the a, I have another x and a y. So I can write 4.5 equals 15, which is our a, times b raised to the 16. And then we're going to do some division, divide both sides by 15. That leaves 0.3 equals b to the 16th. And then I'm going to take the 16th root of 0.3. And when I did that earlier, I came up with b being equal to 0.9275. So now they're asking us, when is there only going to be 2 milligrams left? So, well, I know 2 equals our 15 times 0.9275 to the t, or to the x, because that's what I'm looking for at that time. So I'll divide by 15, and what that'll leave me is 0.9275x equals 2 over 15, whatever that is. And then I'm going to take the ln, or the log of both sides. I'm going to write ln just because it's less. So I'm hoping that what you're at the point where you realize that all you got to do to find x is to take the natural log of 2 divided by 15 divided by the natural log of 0.9275, and that'll tell us our answer. And when I did this earlier, I came up with 26.772 minutes. With this problem there, I'm being told that I start with 368 grams, so I know that's A. And then 165 minutes later, there's only 46 grams. So 0, 368, 165, 46. So we can do the same kind of thing we did in that last equation. 46 equals 368 times b to the 165. We're going to divide both sides by 46 divided by 368. I came up with 0.125. Who would have ever thought that was 1/8? That's raised to the 165. And then we're going to take the 165th root. And that's what b is. And I came up, when I did this earlier, 0.9875. So they want a formula, right? So I'm going to write y equals 368 times 0.9875 raised to the t, or x. Because if this is a myopen math, we'd probably want to say g of t and raised to the t. Oh, I guess I did the wrong problem here, didn't I? So it looks like what I did is I did part B. I did this one. I found the formula. So I got to find the half-life. Well, since I know what B is, I know that 46, since I've got this equation, right, I know that whatever y is divided by that should be 1/2 if I'm looking for a half-life. So 1/2 equals 0.9875 to the t, or to the x. So I'm going to just take the natural log of both sides. And divide both sides by that. So natural log of 1/2 divided by the natural log of 0.9875. And when I did this earlier, I came up with x equals 55. 55, what is it? Minutes? And if you think about this reasoning, if my half-life is 55 minutes, 165 is 3 half-lives. So half of 368 would be 184, and then half of 184 it'll be 92. So that seems like a 92, and they're looking for 46, so that should be another I'm just trying to make sense of this. Half of 368 by half, another half-life, another half-life. So dividing by 2 is what? 184. Divided by 2 again is going to be 92. Divided by 2 again is 46, so that checks. Now, for the last part that we have to do, they want to know how much of the goo will be left after 74 minutes. So we know that 368 times 0.9875 to the 74 will give us our answer. And when I did this earlier, what did I get? I got 145.075 milligrams. So for this last example problem, you have to remember that the balance in a savings account or in some kind of account is equal to the principal times 1 plus the annual rate as a decimal divided by how many times a year it gets compounded, and then you get to raise the number of years times the number of compounds per year. So we're looking for how long to grow $5,000 to $7,900. So that's 7,900 is what our future value is, what we want it to be. We start with 5,000 times 1 plus, let's see, 0.075 divided by 4 raised to the 4 times t, or the 4 times x. So that's our setup. So when I divide 7,900 by 5,000, when I did this earlier, I got 1.58. And then if you take 1 plus 0.075 divided by 4, I came up with 1.01875 raised to the 4t. So now we're just going to do logarithms or natural logs. So the ln of 1.58 equals 4t times the ln of 1.01875. So then I'm going to divide. So I'm going to do this all in one step. So what I'm going to do is I'm going to divide both sides of this equation by 4 times the natural log of 1.01875, because that cancels that all out. 4 times the natural log of 1.01875. And when I did this earlier, I came up with 6.156 years. And those are the examples. Now you're all set to work on those problems on page 3.